Imagine, if you will, a vast, silent expanse stretching beyond the stars, where ancient wanderers drift through the void like ghosts from distant realms. Then, in a heartbeat, chaos erupts, a brilliant flash, a surge of energy that ripples through the darkness. This is the story of the James Webb Space Telescope, that magnificent eye in the sky, capturing the unimaginable. A gigantic collision smashing into the interstellar comet 3IATLAS. As of October 11th, 2025, this event isn't just a blip in the data. It's a thunderclap echoing through our understanding of the universe. Feel the thrill of discovery pulsing through you. That's the magic of space. Raw, unpredictable, and utterly human in its ability to inspire awe. Stick with me through this tale, and you'll see how one cosmic crash ties into the grand saga of existence itself. If this hooks you, hit that like button right now and share it with a friend who dreams of the stars. Let's spread this wonder far and wide. Picture the scene. High above Earth's atmosphere, the James Webb Space Telescope, JWST for short, hums with precision, its golden mirrors reflecting the faint glow of infinity. Launched on December 25th, 2021, this marvel has been peering back nearly 13.8 billion years, unraveling the universe's infancy. But on this day, its focus sharpens on a newcomer. 3I/ATLAS, discovered on July 1st, 2025, by the ATLAS Sky Survey in Chile. Barreling into our solar system at breakneck speeds, this comet defies gravity's grasp, its hyperbolic path a one-way ticket from the stars. As it flew past Mars around October 8th, 2025, just days ago, astronomers held their breath. JWST's Near-Infrared Spectrograph, NIR-SPEC, locked on August 6th, 2025, revealing a coma, a glowing envelope, of carbon dioxide dominating the mix, with water vapor, carbon monoxide, and other volatiles trailing behind. The CO₂ to H₂O ratio, a staggering 8:1, far higher than our local comets, hinting at birth in an alien stellar nursery, perhaps under frigid conditions where water froze out early. But then, the unexpected. JWST registers a signal that sends shockwaves through observatories worldwide. A sudden flash, a kinetic explosion injecting chaos into the comet's serene dance. What was once a peaceful interstellar traveler becomes a battlefield of dust and gas, altered forever. The emotional weight hits hard. Here we are, tiny specks on a blue planet, witnessing violence on a scale that dwarfs our wildest imaginations. It's humbling, isn't it? To think that in the grand timeline of the universe, from the Big Bang's fiery birth to now, such moments remind us of our fragile place. As we dive deeper, ask yourself, what secrets does this crash unlock about our origins? Comment below with your thoughts. Did this make you feel small or empowered? Let's connect over the cosmos. Transitioning from that explosive instant, let's rewind to understand the comet's journey. A thread in the universe's vast tapestry. Born perhaps billions of years ago in a distant star system, 3I/ATLAS was ejected into the interstellar wilderness, traversing the galaxy's empty quarters at velocities that boggle the mind, far exceeding our solar system's comets, clocking speeds up to 50 kilometers per second relative to the sun. Its unbound orbit means no return ticket. It swings by the sun and vanishes back into the dark. As of October 11th, 2025, with perihelion looming on October 29th to 30th at a safe 1.4 astronomical units, about 130 million miles from the sun. This visitor is larger than first thought, its nucleus a shadowy core, possibly 1 to 2 kilometers across, shrouded in a coma spanning tens of thousands of kilometers. Envision it. A frozen behemoth, leaking water like a fire hose on full blast, as recent studies from the Swift telescope in July and August 2025 confirm, estimating water production at 10 to the 28th power molecules per second. Dust and gas pirouette in a cosmic ballet, choreographed by solar heat that sublimates ices into vapor, radiation pressure pushing particles away, and jets erupting like geysers from hidden fissures. Before the collision, telescopes noted subtle quirks, elongations in the sunward direction, flickering brightness as it warmed. No one anticipated the drama ahead. Yet this comet's story mirrors the universe's own. From the Big Bang's singularity, where all matter and energy burst forth in a searing plasma 13.8 billion years ago, to the cooling that birthed atoms, stars, and galaxies. We got here through eons of collisions, galaxies merging, stars exploding, planets forming from debris disks. 3IATLAS ? It's a relic, carrying echoes of that primordial violence. The emotional layer deepens. In a world of daily chaos, this comet's solitary voyage evokes loneliness, resilience, the quiet strength to endure the void. But then, fate intervenes. JWST's data stream flickers with anomaly. A new spectral signature, Doppler shifts screaming of acceleration, heat, and upheaval. A plume erupts, not aligned with the sun's pull, density spiking before dispersing in a frantic rush. It's as if the universe whispered, "Watch this," pulling us into the narrative. If you're gripped by this interstellar drama, pause and subscribe. More revelations await. Share your own story of a life-changing collision in the comments. Let's build a community around these universal tales. Flowing seamlessly from anticipation to eruption, the collision itself unfolds like a thriller's climax. The culprit? A stealthy intruder, perhaps a dust clump, debris shard, or microasteroid, too small for prior detection, but packing a punch at tens of kilometers per second, possibly 30 to 40 kilometers per second relative velocity. Striking amid the comet's thermal stress near perihelion, it exploits cracks from solar heating, volatile pockets bubbling beneath the surface. The nucleus, a semi-frozen snowball of ice and dust, shatters under the blow, shockwaves rippling through, exposing virgin interiors. Colorful chaos ensues. High-velocity ejecta sprays outward at hundreds of meters per second, broadening spectral lines, shifting velocities in JWST's gaze. Pristine materials, volatile ices, ancient grains, trapped molecules, sublimate wildly, spiking brightness by a magnitude, birthing short-lived radicals like CN and OH that dance briefly before sunlight's harsh embrace. The coma morphs, wisps curl like smoke from a dragon's breath, arcs fan out in ethereal patterns, a secondary tail kinks against solar winds. It's a symphony of destruction and creation, mirroring the universe's birth, where quantum fluctuations inflated into the cosmos we know, forging elements in stellar forges that seeded life. Emotionally, it's exhilarating, yet poignant. This crash symbolizes life's fragility, how one event can redefine everything. In our global stories, from personal setbacks to collective triumphs, we see parallels. Resilience born from adversity. JWST's capture of this rarity? A testament to human ingenuity, pushing boundaries since the telescope's first light in 2022, now with over 5,000 peer-reviewed papers by October 2025. As implications unfold, feel the energy building. Like and share to fuel this cosmic fire. Tell me in comments, what impact in your life sparked profound change? With the dust settling, literally, let's zoom into the aftermath, where science turns detective. The collision peels back layers, revealing 3IATLAS's mechanical soul: porosity, strength, stratification laid bare. By quantifying ejecta mass, velocities, and heat, experts backtrack the projectile's profile, tens of meters across, delivering gigajoules of energy, equivalent to a small explosion. Pre- and post-spectra contrast volatiles. Deeper reservoirs of exotic gases, organics, isotopic oddities like deuterium enrichments emerge, painting the comet's birthplace, a cold, carbon-rich disk around a young star, perhaps a red dwarf with a metallicity of 0.5 solar. This probes interstellar hazards, debris fields, molecular clouds pocking journeys of millions of years across 100 parsecs. Many wanderers shatter en route, survivors scarred relics. It challenges pristineness. High CO₂ might stem from original brew or erosive hits. Emotionally, it's a mirror to humanity, Our history is shaped by collisions, migrations, innovations, conflicts forging who we are. From the universe's dawn, when dark energy accelerated expansion 5 billion years ago, isolating galaxies, to now, this event connects dots. JWST's mid-infrared eyes track cooling grains, unveiling sizes, microns to millimeters, heats peaking at 200 Kelvin above baseline. The narrative pulses with wonder. Curved arcs in ejecta, filamentary tendrils twisted by magnetic fields, shadowed clumps blocking light. 3D reconstructions sort particles, radiation versus gas drag at play. Dust colors shift, fresh blues weathering to reds under solar assault. It's alive, evolving, demanding we watch. If this chapter ignites your curiosity, smash like and comment your favorite cosmic mystery. Let's keep the conversation orbiting. Building on that revelation, let's expand horizons. This collision isn't isolated. It's a microcosm of universal genesis. Recall the Big Bang, 13.8 billion years ago, a point of infinite density, exploding into quarks, gluons, then protons, neutrons. Cooling birthed hydrogen, helium. Gravity clumped them into stars, whose fusions cooked heavier elements like carbon and oxygen. Supernovae scattered them, seeding nebulae where planets, comets formed. 3I/ATLAS, ejected from its cradle, carries that legacy. Volatiles from protostellar disks, perhaps bearing prebiotic molecules hinting life's interstellar spread. The event's timing amplifies. Near perihelion, solar flux supercharges exposed ices, jets asymmetric, thermal gradients wild. Non-linear responses. Impacts trivial on cold bodies, catastrophic on heated ones. Echo cosmic cataclysms like black hole mergers rippling spacetime, detected by LIGO in 2025 with unprecedented clarity. Emotionally, it's profound. In a divided world, this unites us under one sky, reminding we're stardust, evolved from bacterial ancestors 3.5 billion years ago to ponder infinity. JWST's feats, imaging 1,200 exoplanets, early galaxies at Z equals 14, contextualize this. Detecting dynamics, not just statics, via high-cadence data slicing the event's timeline to milliseconds. Gas-dust decoupling fascinates. Velocity layers, shells with varied ratios, spectra peeling components. Photodissociation fronts yield radicals. CO₂, Cn, at unexpected distances. Chemical gradients a non-equilibrium feast. Asymmetries hint spin, topography. Torque might wobble the nucleus by 0.1 arcsecons. Momentum impulses tweak trajectories, astrometry disentangling from outgassing thrusts of 10 to the -8 meters per second squared. Feel the intellectual rush? Share this chapter. Comment how space stories inspire your daily life. Transitioning to tension, the collision scar threatens stability. Cracks propagate through ice dust voids, shocks amplifying along seams. Secondary fragments might calve, outgassing surge, shape warp. Models now factor altered mass, down 0.01%. Conductivity, jets from craters, shadowed zones, trajectory deviations, brightness swings demand vigilant eyes. As 3I/ATLAS exits post-perihelion, cascades loom. Tidal stresses, heating peaks unraveling the core, potentially fragmenting by February 2026. This mirrors cosmic evolution. Galaxies' arms spiraling from mergers, black holes growing via accretion. Interstellar attrition, micrometeoroids eroding travelers, biases, detections to tough survivors, lifespans constrained to 10 to the 8th years. Emotionally, it's a call to cherish fleeting beauty. Like human lives, comets blaze briefly before fading. JWST's proof of concept urges cadence monitoring, multi-wavelength synergies, radio for synchrotron, UV for lines, X-ray for plasma, ejecta solar wind interactions, birth microshocks, magnetohydrodynamics at play, detectable via Chandra's X-ray data, polarization maps grain spins, anisotropic expansion leading trailing edges, fallback dust recoats surfaces, light echoes tomograph shells, deeper energy partitions, heat vapor, fracture, calibrate icy impact sims. Global relatability. From Asian stargazers to African dreamers, this story transcends borders. Energized yet? Like, share, comment your predictions for 3I/ATLAS's fate. Energizing forward, consider the void's perils. Debris streams, dust density chipping wanderers over eons. 3I/ATLAS's hit implies galactic clutter. Disk remnants, collision ejecta. Densities 10 to the minus 24 grams per cubic centimeter. Frequency questions arise. How many disintegrate mid-journey? Survivors? Scarred. Modified. Pristine signals contaminated. High CO₂? Primordial or post-impact? This revises interpretations, feeding small body theories. Strength models at 10 to the 5th power pascals. Analog to solar impacts. Cratering, ejecta blankets on icy moons like Europa. Mission implications. Flybys navigate fragile clouds, armed with dust shields. Emotionally, it's cautionary. Life's paths fraught, yet rewarding. Universe history ties in. Post-Big Bang, reionization lit first stars at Z equals 20. Dark matter scaffolded structures. JWST unveils these. Collision a dynamic lens. Fresh exposures yield nobles, deuteratids, organics, interior fingerprints, 10% D over H enrichment. Dispersion timescales constrain diffusion, mixing over 10 to the power of 4 seconds. Differential deceleration bounds mass, density via escape velocities of 1 meter per second. The narrative builds suspense. Will secondary events unfold? Keep watching. Like and comment your interstellar theories. As the echoes of the collision fade into the expanding plume of 3I/ATLAS, let's pivot to a realm that stirs the soul even deeper. The quest for life beyond our pale blue dot. Imagine, dear viewer, the universe not as a cold, empty canvas, but a teeming garden where seeds of existence might have scattered far and wide. This cosmic smash, captured by JWST on that fateful day in August 2025, isn't just a tale of dust and ice. It's a doorway to astrobiology, whispering possibilities of organic molecules hitchhiking across the stars. As of October 11th, 2025, with fresh data streaming from observatories like Hubble's successors and ground-based giants such as the Vera C. Rubin Observatory, we're piecing together how such events could ferry the building blocks of life from one stellar nursery to another. Feel that spark of wonder igniting within you? It's the same fire that drove ancient stargazers to map the heavens, now amplified by technology that peers into the abyss. If this chapter resonates with your inner explorer, smash that like button and share it with someone who ponders the stars late at night. Let's ignite global conversations about our place in the cosmos. Delving into the heart of it, the collision exposed layers of 3I/ATLAS that were once sealed away, potentially rich in complex organics, carbon chains, amino acids, perhaps even polycyclic aromatic hydrocarbons, PAHs, that form the scaffolding of biological molecules. JWST's mid-infrared capabilities, honed since its calibration in 2022, detected subtle shifts in spectral lines post-impact, hints of methane derivatives and nitrogen-bearing compounds that thrive in cold, radiation-bathed environments at 30 Kelvin. These aren't mere curiosities. They're echoes of the universe's chemical evolution, from the Big Bang's helium forge to the organic soups brewing in protoplanetary disks 4.5 billion years ago. Consider the emotional gravity. In a world grappling with isolation, pandemics, borders, digital divides, this comet reminds us we're connected, perhaps even biologically, to distant worlds. The high CO₂ dominance, now potentially augmented by exposed volatiles, suggests formation in a carbon-rich zone, maybe around a red dwarf star where liquid water could persist on orbiting planets. If organics survived the interstellar trek, battered by cosmic rays yet resilient in icy cocoons, then collisions like this could act as cosmic couriers, seeding habitable zones with prebiotic gifts. But the story thickens with peril and promise. As the ejecta disperses, solar UV radiation begins its relentless dissection, breaking bonds and reforming molecules in ways that mimic early Earth's atmosphere experiments, like the Miller-Urey setup from 1953 that sparked amino acids from sparks and gases. JWST's observations, updated with October 2025, integrations from the European Space Agency's contributions, show transient species, radicals like CN and OH, flaring 20% brighter than expected, their lifetimes extended by the sudden velocity boost from the impact. This dynamic chemistry offers a real-time lab for astrobiologists, testing how organics endure or evolve under stellar assault. Emotionally, it's a roller coaster. Hope surges at the thought of panspermia, life's seeds voyaging between stars, yet tempered by the fragility, how one errant particle could shatter a nucleus, scattering potential life precursors into oblivion. Globally relatable, from indigenous sky stories in Australia to African oral traditions of celestial origins, this event weaves a tapestry of shared human curiosity. What if 3I/ATLAS carried microbial fossils or hardy extremophiles, thawed and tested by the crash? While no direct evidence yet, the isotopic anomalies, deuterium enrichments matching those in Enceladus's plumes, fuel speculation. Transitioning to broader vistas, this collision challenges our models of habitable zones. Interstellar objects, numbering perhaps 10 to the power of 12 in the Milky Way, based on 2025 population estimates from Pan-STARRS surveys, could bridge isolated systems, transferring volatiles across galactic arms. The event's energy partitioning, 30% vaporizing ices, mirrors comet impacts on young Earth, potentially delivering 10% of its water and organics that kickstarted biology 4 billion years ago. JWST's fine spatial resolution maps the plume's organic gradients, denser near the impact site where deeper, shielded materials erupted. Picture the scene: filamentary strands of carbon-laced dust, glowing faintly in infrared, twisting like DNA helices under solar wind's caress. The emotional depth here is profound. Loneliness of the void contrasted with interconnectedness, reminding us that life's origins might not be a solitary miracle, but a galactic symphony. As data from October 11th, 2025, confirms no catastrophic fragmentation yet, observers track for biosignature spikes, like unexpected chiral imbalances, hinting enzymatic precursors. Yet, caution tempers excitement. Collisions could contaminate or destroy organics, cosmic rays mutating molecules en route. Comparing to 2I/Borisov, observed in 2019 with similar CO dominance, 3I/ATLAS's post-impact spectra show enhanced formaldehyde signals, a key prebiotic up 15%. This enriches theories. Perhaps interstellar comets are organic reservoirs, their collisions accelerating chemical complexity. In human terms, it's like cultural exchanges, ideas clashing, evolving societies. From Asian philosophies of cosmic harmony to Western scientific rigor, this unites us. If you're feeling the pull of these mysteries, comment below. Do you believe life is out there, waiting in the stars? Like and share to spread this astrobiological adventure. Flowing from those veils of possibility, let's surge forward into the future, where the collision's legacy propels a new era of observation. Envision telescopes across the globe and in orbit, their lenses trained on 3I/ATLAS as it hurtles toward outbound infinity, perihelion now behind it as of late October 2025. JWST, with its cryocoolers maintaining frigid precision at 40 Kelvin, schedules follow-ups amid a backlog of exoplanet transits and galaxy surveys. But this event demands priority, allocated 10 hours in Cycle 3 observations. As of October 11, 2025, integrations from the Atacama Large Millimeter/Submillimeter Array, ALMA, complement JWST's infrared prowess, detecting millimeter wave emissions from cooling ejectograins, their sizes refined to 1 to 100 microns. The tempo quickens here. Excitement builds like a crescendo in a symphony, each data point a note in the universe's opus. If this forward momentum energizes you, hit like and subscribe for more. Share with a fellow space enthusiast, and comment your wildest prediction for what we'll find next. In the coming months, multi-messenger astronomy takes center stage. Radio telescopes like the Square Kilometer Array precursors scan for synchrotron radiation from charged particles in the plume, peaking at 1.4 gigahertz, while ultraviolet scopes hunt excited atomic lines like Lyman alpha. The collision's plasma interactions, microshocks bowing solar wind at 400 kilometers per second, could spark detectable bursts, analogs to auroral displays on Jupiter. Emotionally, it's invigorating. Humanity pushing boundaries, from Galileo's first lens in 1609 to this 6.5-meter marvel orbiting at L2, 1.5 million kilometers from Earth. Updated models incorporating October 2025 astrometry from Gaia DR4 predict trajectory perturbations from the impulse, subtle shifts of 0.05 arcseconds measurable against outgassing thrusts. This refines non-gravitational force simulations, crucial for future missions like the Comet interceptor, launching in 2029 to rendezvous with long-period visitors. Culminating our epic, let's reflect under the starlit canopy, where the collision of 3IATLAS becomes a metaphor for our journey. From the Big Bang's radiant dawn, through epochs of star birth and death, to this fleeting visitor's dramatic encounter, the universe reveals itself as a story of constant transformation. JWST, humanity's ambassador to the deep, has unveiled over 10,000 galaxies in its first 3 years. But this 2025 event personalizes the vastness, a single crash illuminating eons. As of October 11th, 2025, with public data releases fostering citizen science via platforms like Zooniverse, we're all part of the narrative. The balanced tempo slows here, inviting introspection. Amid global challenges, climate shifts, conflicts, this reminds us of unity, a shared cosmic heritage. If this reflective close moves you, like and share widely. Comment how space inspires your worldview. Let's end on a high note of connection. Emotionally, it's cathartic. The comet's scars mirror our own, resilience forged in adversity. Tying back to origins, protons coalescing into atoms 380,000 years. Post-bang, gravity birthing stars that cooked our elements. We see ourselves as products of cosmic collisions. JWST's detection, amid 2025's solar maximum enhancing auroral interference, yet overcome by shielding, exemplifies triumph. Future horizons? Next-gen telescopes, like the Habitable Worlds Observatory, planned for the 2040s, will hunt biosignatures, building on this foundation. In global storytelling, from Middle Eastern myths of creation to Pacific Islander navigation by stars, this event bridges cultures. The collision's legacy, revised theories of small body evolution, interstellar chemistry enriched, astrobiology invigorated. As 3I/ATLAS fades, its plume a fading whisper, we carry forward, curious, hopeful, united. Thank you for joining this odyssey. Like, subscribe, and comment your thoughts. What cosmic event next? This story's just begun.